All right, so we're going to talk about area and Riemann sums. So tell me what you know about the units on area. They're squared, okay? Do you think that like every time you've done area, they're units squared, right? Because it's like base times height, so you have like inches times inches, you end up with inches squared, right? Well, it's not really an always thing. It's kind of an always thing in geometry when you're talking about figures, but when we start putting this on graphs and finding area, you have to not think about it as the units are always squared. You're always multiplying units together, but that doesn't always result in units being squared, okay? So tell me, well, let's read this. It says, in this example, a car is traveling so that its velocity is never decreasing, so it's always increasing, in a 12-second interval. The speed at various movements in time is listed in the table below. So we want to estimate the distance traveled. So it says estimate, which means we're not going to be able to find it exactly. So we're going to estimate the distance during the 12 seconds. Okay, so let's just talk about, before we read the rest of the sentence, how do you find distance? Think back to your physics days. Distance equals what times what? You remember? Velocity times time, yeah. Velocity is distance over time, so distance is velocity times time. Does that make sense? Okay. So distance is velocity times time. Does that make sense? All right. So it says traveled by the car in the 12 seconds. So let's make a little graph here. So I know we're going 12 seconds, so we'll make it 12 out here. This is our time. This is in seconds, right? And my velocity, it's never decreasing, which means it's always increasing. So we're going from 30 to like 65-ish. So let's say that this is like 30, and we'll make this like 60. So since it's increasing the whole time, it's not necessarily a straight line, but it's something like that, right? Oops, starting at 30. Make sense there? So it says we're supposed to estimate it, travel by the car during the 12 seconds, and this is seconds, this is velocity, which is feet per second, by finding areas of 4 rectangles drawn at the heights of left endpoints. This is called a left Riemann sum. So we have left-hand triangles, right-hand triangles. So we're going to estimate the area because we know how to find areas of things, right? But this shape, whatever it may be, that's something, we don't have an area formula for that, right? But we know, do you know how to find the area of a rectangle? Yes, length times width or base times height, right? So here I am at 12, I'm supposed to use 4 rectangles. So that means I need to divide this into 4. So 12 divided by 4 is what? 3. So it's going to be at 3, 6, 9, and 12, right? So I'll have, there it is, and 4. So this is at 3, 6, 9, and 12. I have separated it out evenly. Make sense? Okay, so then I'm going to draw from each one of these a line up to my graph, like so. And I'm supposed to use rectangles with a left endpoint. So left-hand rectangles start from the left. Okay? You don't draw to the left, you start at the left. So if I'm going to make a rectangle out of this spot right here, I start at the left-hand side of where the graph is, and I make a horizontal line so that I've made a rectangle right here. Then for this spot right here, I'm going to start right here. Start at the left and draw over. Here's a rectangle right here. Okay? And then from here to here. So there are my 4 rectangles. Now, is that going to give me the exact areas under the curve? No, but it's going to give me an estimate, right? Is that going to be an overestimate or an underestimate? Underestimate. And so we already said that distance is velocity times time. This is your velocity. This is your time. That's why we are finding area, because you told me we can find the area of the rectangle by length times width. That's going to be your velocity times your time. Does that make sense to you? All right, so when I do that, let's just think about units. When I do that and I get my velocity, which is feet per second, and I multiply it by my time, which is seconds, what are the units on my answer? Feet, because it's distance. So even though we're finding area, you see how it's not units squared? Does that make sense? Okay, so every time when you do this, what I want you to do is before you do anything else, you come over here and you take your units and you multiply your units together and figure out what your final unit is. And sometimes your final unit won't make sense, okay? It might be, you know, I don't know, it doesn't even matter, but it could be seconds over feet or something like that, which that might not make sense, but it might end up being what happens. You just do what it says. So those units are important, okay? So your distance then, your distance, which is velocity times time, is about, right? And then we find the areas. Base times height. What's the length right here? 3. So I'm going to multiply 3 times the height here when x is what? 0. When x is 0, my height is 30. Plus, then this is 3 times the height when x is 3, which would be 37. Plus, what is this? 3, and they're not all always the same, so be careful. 3 times the height when x is what? 6, which is 45. Plus 3 times when the height is 9, 54. We're going to stop. Yeah, we stopped there because these are we have 4, right? And when you have left-hand rectangles, your rectangles are determined by the height of the left-hand side. Okay, so everything's moved to the left. So we're not using this one because we didn't go all the way up there. Does that make sense to you? And we are not going to, this is a safe stop. We it's a multiple choice, we're not multiplying it out. Do you want to make a mistake on multiplying 3 times 54? No, you don't, right? And so we can bracket this, and we have feet. And there's our answer. It doesn't ask us to explain this, and it's not always good. Sometimes it will, sometimes it won't, but we're going to write out an explanation this one time here just to make sure we can explain it correctly, right? And we're going to say that, so it says estimate the distance traveled by the car, da, 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 da. Okay, so the distance traveled by the car during the 12 seconds is, here's a very important word, approximately and then we're going to put this in here, this many feet. Well, I probably should have done that differently. Probably should have said this is the distance, approximately, sorry. I was writing it like I had an answer. But the point there is that you have to say approximately. You have to say approximately. Okay, so here, then I want you to write, for left Riemann sum, I want you to write height of left side of rectangle. Well, just left side is fine because it's rectangles. We okay with that? And you see how your sketch of your, like I could have actually tried to plot these points nicer, but it really doesn't matter because we're not pulling it off the graph, we're just getting the idea of it. All right, so let's look at this next one. So this says estimate the distance traveled by the car during the 12 seconds. So the same thing, 4 rectangles again, drawn at the heights of the right endpoints to do right Riemann sums. So we're still going to go out to 12, and divide it into 4. So if I'm going to divide something into 4, I'm going to divide it in half and then divide it in half again just so it looks decent. Because it's, I mean, nobody's grading that, but you don't want to confuse yourself. Right? So the graph itself is going to be pretty much the same, something like this. And then I'm going to do the same thing. So since I'm dividing it into 4, I'm going to, I need to make that. I'm going to draw my vertical lines. But this time when I draw the top of my rectangle, these are right Riemann sums, like it's telling me what to do. That means in this interval right here, I start from the right-hand side and draw to the left. So when I'm at 6 here, I start here. I'm drawing to the left, but I'm starting at the right. It's about where you're starting, not where you're going to. And then your rectangles will look like this. Now, is that going to give me the exact area under that curve? No. Do you think it's better or worse? Or can you even tell? Probably can't really tell, right? Plus, is my graph actually accurate? No. So if you're going to try and tell by looking, like, we don't know. But we can tell that it's, even if my graph was accurate, it's still going to be an overestimation where this one is an underestimation. Does that make sense? All right, so then we can say, and then I'll reword this one a little bit differently so it makes more sense. So our distance is about, right? And then remember, we need units on here. These are our seconds. This is feet per second. And so we're going to do feet per second times seconds, which means our units in the end are feet again. So we're going to start with, what's this width? 3. What's the height of that rectangle? 37, because it's when x is 3, right? 3 times 37 plus, and so all of our widths are 3 on this one. That's not, again, not always going to be the same. Then this one will be 45, right? So you finish this part up. It's a different color. And then this is, the distance is approximately, that's what that means. That's why we're not putting equals, it's approximately, right? So then I can say then this is the approximate distance the car traveled how was it worded? During the 12 seconds, yeah. And you have to be careful. Also, maybe the question could say, how far is the car from the house? And it started 30 feet from the house. Then you'd have to add 30 to that at the end, right? So make sure you're reading the questions and that you're answering the right things. All right, so left hand and right hand, do you understand how to draw them? Okay, and so the left hand is an underestimate, the right hand is an overestimate. Do you think that would always be the case? And if not, when would a left hand not be an underestimate and a right hand not be an overestimate? If it was decreasing instead of increasing, would that make sense? Because if I'm decreasing, let's just say that if I'm decreasing, then I'm going the other way, things flip around. That's very good. When's another time? That's what I was going for, but there's another answer. That's true too. When would it be the exact area? when it's a horizontal line. If I had a horizontal line, then would it be an overestimate or an underestimate? It would be the exact one, right? But you're right. If it's decreasing, it's going to flip around, and we're going to look at one of those. So that's a very good observation. Okay, so now let's talk about the midpoint rectangles, because we have to know how to draw all of these. But one thing also I want you to make sure you understand, so that you need to be able to draw them. You're going to have to draw them, but you don't always have to draw them to do it. If you know that you have a left-hand sum, then you are using the height of the left hand, so you start at the left and you use this. If you have a right hand, you're using the right hand height, so you start here to use those 4, okay? But it's probably safer to at least sketch it out quickly. It doesn't have to be beautiful, but that way you don't get it backwards on which one you're doing, okay? All right, so let's look at this. So same thing, we still have 12 seconds. It's still, but this time it says 2 rectangles. So we're going from 12, this is at 30. We'll just put a 60 up here just so I can get the bearings there, something like that, right? So I only have to have, this says areas of 2 rectangles. So if it's the area of 2 rectangles, I can put my 6 right here, and then I can draw my 2 rectangles like so, okay? But these are not left hand, these are not right hand, these are midpoint Riemann sums or midpoint rectangles. So I have 2 intervals that are 6 units long each, right? So I go from 0 to 6, halfway is at 3. That's the midpoint of my interval. I find that on the graph right there. That's the height of my rectangle, so then I just draw it from the left and the right like so. So then the midpoint between 6 and 12 is right here at 9. So at 9, I go to my graph. Here's my point. And I get that. So these are my 2 rectangles. I don't think I shaded in the other ones, which is fine. You don't necessarily need to shade them. I just want to make sure you know what you're looking at here. So then the distance is approximately, and again we have seconds and feet per second. So feet per second times seconds is going to give you what? Feet, not feet squared, which should make sense because it's distance, right? So what is the width of my first triangle? 6, because this right here is 6. And then I'm going to multiply that by the height, which is the midpoint. So I get the y value when x is what? 3. And what do we get? 37. Plus, the next width is also 6. Again, they're not always going to be 100% the same. These two happen to be. And then I need the height when x is 9. The height is the y value, which is 54. And then this is feet. Okay. And then the height is the midpoint of the interval. Okay. We don't have to write out an explanation. We all good? So we have left hand, right hand, midpoint rectangles. Now let's talk trapezoid. We've got the same function, so we'll go ahead and get our little graph done here. Okay, so I'm here at 12. This is seconds. We got 30 and 60, and this is feet per second. Okay, so it's something like that. And I would need 4, which means I'm going to take that 12 and divide it into, from 0 to 12, I'm going to do 4 equal intervals. When you do them, you're usually going to, when you come up with them yourself, they're going to be equivalent intervals. Sometimes when you're given a table, they're not the same. That's when it's, ooh, goodness gracious. Lean on the board again. So we got 3, 6, and 9. So same thing. We're going to draw our vertical lines. So that's the same every time. But this time they're trapezoids. And I probably should have drawn my line a little squigglier to help it out. Maybe I'll do that. I'm going to redraw that. I don't know, something like that. When it's never decreasing. Because otherwise, if it looks horizontal like mine did, then it's, or not horizontal, just completely straight, then things don't look as good. All right, so then we just connect the dots, basically. So does this look like it would be an overestimate or an underestimate, you think? Under, for the most part, yeah. Did you see how the other way I had it drawn, it was almost just a straight line, so it just looked like it hooked up, which, I mean, it is a much better estimate for this particular graph, but that's not necessarily always going to be the case depending on what it is either. So I have these these aren't four rectangles, these are what? Trapezoids, okay? So I used to do a lesson similar to this in geometry when I taught pre-AP geometry. And we would draw this, and I wouldn't say, the word trapezoid wouldn't be in here yet, so we'd draw them, and then I'd say, what are these shapes? And I'd be like, crickets. And then somebody would, every class period, every year, pentagons. Where do you get 5 sides from? There's not pentagons, there's 4 sides, it's a trapezoid. But it's a trapezoid that probably looks sideways to what you're used to looking at, right? So if you're, the way that trapezoids, you know, when you first learn them or whatever, they're drawn like this. They're not drawn standing up on end, but it's still a trapezoid, right? So we have 4 sides, you have the bases which are parallel, and then you have the legs. So these are the parallel parts. These are the bases of my trapezoid. So not only do you have to recognize that it's a trapezoid, which is a good thing in calculus, if it tells you to use a trapezoid, the word's right there. But you have to know how to find the area of a trapezoid. Like that's a formula you have to know. They are not going to give it to you. You write down what you think it is. Just write down what, I'm not going to make you say it out loud. You just write down what you think it is. The area of a trapezoid. Right. Shh. I said write it. I didn't say see it. What if it's wrong? If it's wrong, you mark it out and you fix it. It's fine to be wrong. I'm wrong all the time. There's 2 different ways to write it. I'm going to tell you, and I'll kind of give you 2 different ways to remember it and tell you why I like one more than the other, especially when I taught geometry. But so one formula for the area of a trapezoid, I mean the formulas are the same, is 1/2 base 1 plus base 2 times the height. Okay. Another way to write that same thing, depending on your outlook on how you remember the formula, is you could say that the area of the trapezoid is base 1 plus base 2 over 2 times the height. You could also put the height in front of the parentheses, but I'm going to tell you why I do it in this order. So the reason I stopped ever using this when I was actually teaching area was because then when you get fractional bases, you automatically get a fraction and people's heads explode. So if you have a fraction like this, that's not so bad, right? I mean, you just multiply straight across, no big deal. But, so here's how, okay, back to a little geometry lesson. I would talk about trapezoids. So if we have a triangle, let's just say, you don't have to write this down, just stay with me here. Oh, I didn't mean to make it look isosceles. It can be really any triangle, whatever. So we have a triangle, and we know to find the area of a triangle, that is what? 1/2 base times height. Like that one shouldn't be a struggle for you, right? So if you think about a triangle, if you think about a trapezoid being a triangle that gets its head cut off, and so here is what we have now that makes this a trapezoid because these are parallel. So it's the same thing, you just have 2 bases. That's what makes the area of a trapezoid 1/2 base 1 plus base 2 times the height. So if you relate it to a triangle, that should help you. Does that make sense to you so you don't do anything weird? All right, the other thing is, I know our sleep schedules are off. Y'all wake up. Y'all wake up. I know, I'm tired too. My sleep schedule's off too. It's the average of the, so if you write it the other way, oops, If you write it the other way, it's the average of the bases times the height. So you can think of it however you want to think of it. Just make sure you can do it correctly. That's what I'm saying. We got it? Okay. All right, so let's talk about the approximate distance. All right. So we know, again, we have feet per second times seconds. And that leaves me with feet. I know we did the exact same thing 4 times, right? Come in here and start sleeping. So I'm going to do the area of the first one. So I know it's 1/2. And then you have to remember, even though a lot of times we write or we draw trapezoids like this, these are turned on their sides, right? So the bases are the vertical parts. Base 1, base 2. So base 1 we get when x is 0. So that when x is 0, we get 30. Plus the other base, which is 37. Then we multiply that times the height. The height is always, for anything, the distance between the bases, which is what? 3. You understand where you get that from? If you needed to, seriously, I can't do this with my board, but if it helps you to turn your paper and do your work sideways so that you can see the bases parallel horizontally, do what you got to do. Then we're going to do this second one right here. So it's going to be 1/2 times, for this one, base 1 is when x is 3, which is going to be 37, plus base 2 is when x is 6, which is 45. Then we multiply it by the height, which is the distance between the bases, which is 3. Plus, can you finish it up? Write the rest of it out, see, and then you can check yourself with me. Are we good? It's a formula you got to know. All right, what questions you got? Okay. So it says, given the function y equals negative x squared plus 9, estimate the area bounded by the graph of the curve in the x-axis from 0 to 2 by using blah, blah, blah. Okay? So first we're going to have to graph this, but we're going to actually graph this a little bit better because we don't have data to go by. Like, we need to know how to graph this. First of all, what is this going to be a graph of? Very good. Yes, the function of y. And since it's negative x squared plus 9, what does that look like? It's a parabola that opens down, right, because it's negative. And what does that 9 do to it? Moves it up, right? Does it move it left or right any? No. Okay, so our vertex is usually at 0, 0. It's going to be lifted up 9 to get here. So this is 9, right? And we know it opens down, okay? So it's going to open down, something like that. Now, we're only going from 0 to 2. So I got to figure out basically where 2 is. Like, I don't have to plot it exactly, but I need to know if it's inside or outside this, right? So when y is 0, what would x have to be? 3, right? So because if I put 3 in here, negative 9 plus 9, so this right here, this is at 3. I only have to go to 2, so I can just put my 2 right there. Like, it doesn't even have to be super accurate. We'll put 2 there. Okay. All right, so then we have a left Riemann sum. So left with n equals 4 subintervals. So that means I got to split this into 4 equal parts. Halfway is at what? It's halfway between 0 and 1. 1/2. What's halfway between 1 and 2? 3/2. 1.5. Smack you. 3/2. So now take that and draw your 4 left-hand triangles. Triangles, oh my God, 4 left-hand rectangles. So remember, we're going to draw to the graph no matter what. Then do we start on the left or the right? The left, because it's a left-hand rectangle. Oops. I don't. We're not gonna worry about finding it. Now, is this an overestimate or an underestimate? Over. Now, you see on mine how it looks like part of it is under? That's because my graph isn't great. Because look at how I drew it. Like from here, I kind of went up. And is that really what's happening with a parabola? It's not going up from 9. So that's just kind of bad on my part on the graph. It's not the end of the world. I'm not going to redo it. But it should all look like it's an overestimate if you drew yours better than mine. But there are your 4 rectangles. Okay? So then we're going to draw this one, then we're going to come back and talk about these two. I'm going to let you do this one. So basically, the graph is the same. So we're going to start here at 9. I'll try and do a better job of actually not going up first. Something like that. And then I'm here at, we'll make this 2. Then you're going to have to divide it into 6 equal rectangles. So you figure out what that's going to have to look like. Mm-hmm. Mm-hmm. Exactly. So we went to 2. If you do 2 divided by 6, that gives you the widths of your intervals. Then you should be able to mark out your x values. So if you're dividing stuff up and what you're trying to divide is an even number, like I can go ahead, I'm dividing by 6, I can divide this in half and get to 1. And then if each half I divide into thirds, wouldn't I have 6 pieces? So this would be 1/3, 2/3. And then do I have to think real hard on these? 4/3 and 5/3, because as Adrita said and how I tried to teach y'all the unit circle last year, think fractionally. You got 1/3, 2/3, 3/3. That makes this 4/3 and 5/3. So you draw your right-hand rectangles, and then we're going to be done for today.